Hello everyone, my name is Chance Walker, and today I will be talking to you about the challenges tidal power is facing. Throughout this video, we will be discussing multiple factors that hinder this fairly new form of power generation's ability to potentially become a better and more efficient form of power generation than those we are all used to and see in our day-to-day lives, including common forms such as solar and wind power generation. First off, let's discuss the basic process behind tidal power generation. Tidal energy is primarily a result of the gravitational interaction between the Earth, the Moon, and the Sun. The gravitational forces exerted by the Moon and Sun cause the rise and fall of ocean tides. As the tide comes in and goes out, it carries a significant amount of kinetic and potential energy. When tidal currents flow, they possess kinetic energy due to their motion. And as the water levels rise and fall, there is also a change in potential energy. Tidal power generation aims to capture and convert these forms of mechanical energy into electrical energy using electromagnetic induction. Tidal power generation has two main systems that can be used to effectively create and store power: tidal stream systems and tidal range systems. Tidal stream systems use underwater turbines similar to those used in wind power. The kinetic energy of moving water turns the turbines, which then generates electricity. Tidal range systems take advantage of the potential energy difference between high and low tides. Tidal range power stations often use barrages or dams to trap water during high tide. When the tide recedes, the stored water is released, passing through turbines to generate electricity. To the right of the screen, we can see a simple sketch of a tidal turbine, which would be considered an example of a tidal stream system. The turbine is placed below the surface of the water, and the base of the turbine is buried beneath the water body's floor. As the tides change, the tidal current begins to push against the blades of the turbine, causing it to rotate and generate energy, which is then converted into power and stored in a designated location on the tidal power system. Tidal energy generation is renewable, as the high load tide cycle is an infinite natural loop which can be easily predicted in most locations. This energy generation also produces little to no greenhouse gas emissions, making it more environmentally friendly than competing power generation systems. There are two main challenges that tidal power is facing, and those come down to cost and permitting of construction, and the newly discovered environmental impacts tidal power generation causes. So, why cost? Well, let's take into consideration the comparison of wind versus water in terms of density, force, presence, and space. As you can see in the bottom left figure, water is far denser than air, with air having a density of around 1.3 kilograms per meter cubed, and water having a density of roughly 1,000 kilograms per meter cubed. Doing the math, this makes water around 800 times denser than air. With this density, the materials going into a tidal power system must be able to withstand the immense force behind water in large quantities. Most wind turbines consist of mainly steel components, which is a relatively common material, while most tidal turbines are made from glass or carbon fiber reinforced epoxy, which is a much less common material, subsequently costing more to produce in large quantities for standardized use. Wind is also a more attainable substance. Tidal turbines are restricted to large bodies of water with a strong high low tide cycle, where wind is virtually everywhere, allowing wind turbines to be built almost anywhere around the world. These restrictions and material qualities make the cost of tidal energy much higher than a common generator such as wind. Now, we will move into the issues regarding permitting. In terms of permitting, to be allowed the opportunity to construct and implement a tidal turbine or other tidal power generation facility, you must go through numerous regulatory agencies and commissions. Groups such as the Federal Energy Regulatory Commission, which is leading in hydroelectric project permitting, and the U.S. Army Corps of Engineers have strict guidelines and regulations one must comply with in order to implement a device such as a tidal turbine. At the state level, there are mandatory conditioning authorities that control coastal zone management, which vary from state to state. To obtain leases and easements, to allow for construction and land or water body usage, one must comply with the state conditioning authority's set of rules and regulations, which are not always favorable to tidal power generation systems. There are also many acts that preserve aquatic domain ownership, as well as aquatic life and habitats. These include the Clean Water Act, the National Historic Preservation Act, the Fish and Wildlife Coordination Act, and the Marine Mammal Protection Act, as well as many others. These acts are another deciding factor in the implementation of tidal energy generation in the U.S., as well as around the world. With all of these issues regarding permitting, the allowable area available for tidal energy generation around the world is again cut down, making it even harder for this emerging technology to flourish and gain popularity. Next are the environmental issues associated with tidal power. In recent years, we have seen the emergence of conservation and protection issues regarding tidal power. There have been instances of habitat destruction, including both deep water and coastal ecology disruption, which have been linked back to the presence of tidal power systems in the area. Salinity shifts in the oceans have also been linked to tidal power generation. This issue is still fairly new, and there is not much evidence in regards to the environmental issues being a direct cause of tidal power systems. However, this does not mean that these devices are not causing the destruction and disruption. With more research and testing in the coming years, hopefully this issue is solved and changes can be made to improve the equipment used in tidal power generation. But what about reliability? Many people are skeptical on the reliability of tidal power generation. The question of consistency has come up many times due to the unpredictability of nature. However, tidal power may be one of the most consistent forms of power generation to date. The high-low cycle is one of the most consistent natural processes, being far more consistent than wind or solar. Wind conditions can vary hour to hour each day, as well as having variance from region to region. Solar conditions rely solely on weather conditions. If there are, say, a week's worth of cloudy days in a row, solar power production in an area can decrease drastically. Tides also produce a much larger energy output than solar or wind. Due to its increased density and force working on the turbine generators, tidal currents can generate more energy per unit area than wind or solar. So, to sum things up, tidal power can be a reliable source of energy. The consistency, reliability, and predictability of high-low tide cycles provide a steady and plentiful power generation that is both renewable and cleaner than competing power generation techniques. However, the issues involving cost and permitting are hindering development and implication, and emerging environmental impacts are causing growing concern. With this field being fairly new, further research and testing is needed to fully understand the risks and benefits of tidal power. And until then, this power generation method may remain niche in most parts of the world. Thank you all for watching this video, and I hope everyone has a great day. Goodbye for now.